Hello, welcome to this presentation. I am Samuel Oweye, popularly known as S.O PienS. Now, we're talking about the overview of renal physiology. So before we proceed, let's have the outline of this presentation. Now, we start with introduction. Number 2, we look at the physiologic anatomy of the kidney. Number 3, we look at the nephron. Number 4, we look at the urine concepts. Number 5, we look at micturition and micturition reflex. Number 6, then we look at renal pathophysiology, function test, and diuresis. Okay, now starting with introduction. Now, renal physiology is an important aspect of physiology that deals with the study of normal functionality of the kidney, okay, and its related structures. So the kidney has a close communication with the extracellular body fluid. Okay, now let's briefly talk about the body fluid before we can understand very well the concept of renal physiology. The body fluid is divided into the intracellular fluid and extracellular fluid. The body fluid has total amount of 42 liters of water, because water is a major fluid, so it's about 42 liters. Then the ICF is about 28 liters. Then the ECF, that's extracellular fluid, is about 14 liters. The extracellular fluid is further divided into the blood plasma and the interstitial fluid. The blood plasma is about 3.5 liters. The interstitial fluid is about 11.5 liters. Okay, but we have other body fluids such as the cerebrospinal fluid, intraocular fluid, the glandular secretions and fluid in the GIT, the synovial fluid, the peritoneal fluid, pericardia, and the pleural fluids. Now, all these fluids together form another fluid that we call the transcellular fluid. Okay, now most of the functions of kidney results from its manipulative ability, of the extracellular fluid, how it can manipulate the extracellular fluid, to control its contents. Okay, now the blood passing through the kidney is actually filtered. Okay, the filtrate is altered by tubular secretion and reabsorption, so releasing the final products into the renal pelvis. From there, it enters into the ureter and temporarily stored inside the urinary bladder. Alright, a nervous reflex eventually trigger the voiding of the fluid, that's the urine, into the exterior via the urethra. Okay, a process that we call micturition or urination. Okay, so roughly speaking, if we were to look at the excretory units, we have the 2 kidneys, followed by the 2 ureters, followed by the empties into the bladder, urinary bladder, then to the urethra. So the kidneys are paired, the ureters are paired, the bladder is unpaired, the urethra is unpaired. All right. Now let's talk about the physiological anatomy of the kidney. That's the second part. Now, the anatomy. The kidney is a paired, bean-shaped retroperitoneal organ that is located in the posterior abdominal wall. Alright? It has over 1 million excretory units that we call nephrons. It is surrounded by a fibrous capsule. Its inside is divided into cortex and medulla. Okay? The medulla is segmentalized into renal pyramids and open into renal pelvis via the papilla. Okay? Talking about the physiology now, the physiological function, the physiology of the kidney. Now, the kidney is an important hemostatic organ that has many regulatory functions, but the ultimate function of the kidney is the formation and excretion of urine. Alright, so now let's have the list and explanation of those functions of the kidney. Number 1 is excretion of metabolic waste products and foreign chemicals, that's xenobiotics. Number 2 is the regulation of water and electrolyte balances. Okay, now regulation of water balance. the formation of dilute and concentrated urine. For dilute urine, increase in water intake increase body water content, which decrease the body osmolarity. Then this causes decrease in antidiuretic hormone secretion, that's ADH. Decrease in ADH secretion decreases water reabsorption in the distal renal tubule, therefore increasing more water in the renal tubule, resulting in excretion of diluted urine. Okay, that's how the kidney excretes dilute urine. For concentrated urine, opposite happens actually. Decrease in water intake decrease body water content, which increase the body osmolarity, and that will increase the ADH secretion. Increase in ADH secretion increases the water reabsorption, in the distal renal tubule, and decreasing water in the renal tubule, okay, resulting in excretion of concentrated urine. Okay, another factor that is responsible for formation of concentrated urine is the hyperosmolarity of the medullary interstitium, which is brought about by countercurrent mechanism, a mechanism that increases the urine concentrating ability of the kidney. Okay, so another important function of the kidney is the regulation of arterial blood pressure. The kidney regulates the arterial blood pressure in two ways: by regulation of extracellular fluid volume, that's through pressure natriuresis and diuresis, by the use of renin angiotensin system, okay, through the juxtaglomerular apparatus, which consists of the juxtaglomerular cells, the lacy cells or extraglomerular mesangial cells, and the macula densa. Okay, the juxtaglomerular cells is formed by the cells of the afferent and efferent arteries that are close to the macula densa. Okay, and they secrete renin. The juxtaglomerular cells secrete renin. Now, another important function of the kidney is the regulation of acid-base balance. Okay, regulation of acid-base balance. This is done through the use of different buffering systems: ammonia buffer system, bicarbonate buffer system, and phosphate buffer system. But the kidney regulates the extracellular fluid hydrogen ion concentration in three major ways. Number one is the secretion of hydrogen ion, that is excretion of hydrogen ion, of course, the reabsorption of fetal bicarbonates, and the production of new bicarbonates. Okay, so that is how the kidney regulates the acid-base balance of the body. Okay, kidney also have the hemopoietic function. Okay, that is through the secretion of erythropoietin. Okay, it also have other endocrine functions like it secretes thrombopoietin, renin, vitamin D3, that is 125 dihydroxycholecalciferol. Okay, it also releases kinins. Those are locally produced autocoids and prostaglandins. Okay, now regulation of body temperature. Yeah, the kidney regulates the body temperature. Okay, also regulation of blood calcium level. All right, it regulates the blood calcium level by controlling the reabsorption and secretion of calcium ions in the renal tubules. Then also very important, the kidney also undergo what we call gluconeogenesis. It produces new glucose from non-carbohydrate precursors. Okay, so these are the major functions of the kidney. All right, now let's go to the second part, which is renal circulation. Now the normal renal blood flow is 1,100 ml per minute for the two kidneys. The renal blood vessels organization. Let's have an overview of the renal blood vessels organization. The abdominal aorta gives rise to the renal artery. The renal artery gives rise to the segmental arteries. Segmental arteries give rise to the interlobar arteries. The interlobar arteries give rise to the arcuate arteries, to the interlobular arteries, to the afferent arteriole, to the glomerular capillary, to the efferent arteriole, okay, to the vasa recta or peritubular capillaries, depending on the type of nephron, as we're going to see later. Vasa recta in the juxtamedullary nephrons, peritubular capillaries in the cortical nephrons. Okay, then from there to the peritubular venules, to the interlobular veins, to the arcuate vein, to the interlobar veins, to the segmental veins, to the renal vein, then to the IVC, that is inferior vena cava. Okay, but please note that in the course of the circulation, we realize that there are two major capillaries which substantiate the reason why the kidney has what we call a portal system, portal circulation. Portal circulation has two major capillary beds: the primary capillary bed and the secondary capillary bed. So we have the glomerular capillary and the peritubular capillaries. Okay, the glomerular capillary is the primary capillary bed. The peritubular capillary is the secondary capillary bed. It's a rare feature, that's present in some peculiar organs like the kidney, like the liver, okay, like the brain, the hypothalamus and the hypophysis and the pituitary gland. Okay, that are the major locations where we can see the portal system or portal circulation. All right, the kidney regulates its own blood flow and glomerular filtration rates, that is autoregulation, by two major mechanisms. Number one is myogenic mechanism. Number two is tubuloglomerular feedback mechanism. The myogenic mechanism involves the reflexive vascular muscular contraction, okay, and relaxation following increase or decrease in the blood flow or pressure to the kidney respectively. Now let me take it again. The myogenic mechanism has to do with the reflexive vascular muscle contraction, okay, as when there is increase in blood flow or pressure, and there's reflexive vascular muscle relaxation following decrease in blood flow, okay, or pressure. All right, so that is the myogenic mechanism. The tubuloglomerular feedback mechanism has to do with the juxtaglomerular apparatus. Now decreased sodium chloride in the renal tubule, increased renal blood flow and GFR, and vice versa. That's for the tubuloglomerular feedback mechanism. The juxtaglomerular apparatus, the macula densa, these are cells that form the wall of the early distal tubule. Okay, the juxtaglomerular cells are in the wall of the afferent and efferent arterioles, which secrete renin. Okay, and the lacy cells or extraglomerular mesangial cells, they secrete some autocoids. Okay, now before we proceed, let's have a short break. I will be back after this timeout. Relax. Right, so welcome back. Now let's go to the third part, which is talking about the nephron. Now, the nephron is the structural and functional unit of the kidney. It has two major parts: the renal corpuscle and the renal tubule. The renal corpuscle consists of the glomerular capillaries and the Bowman's capsule. Okay, the glomerular ultrafiltration takes place in the renal corpuscle. The renal tubule consists of the proximal tubule with straight and convoluted parts, the loop of Henle with the descending and ascending parts that have the thick and thin segments for each part. Okay, for descending you have thick and thin parts, for ascending you have thick and thin parts. Okay, then we have the distal convoluted tubule, that is the early, which has the early and the late parts, and finally the connecting tubule, which connects the nephron to the collecting ducts, which are the cortical and the medullary collecting ducts. Okay, the tubular secretion and reabsorption take place in the renal tubule. All right, let's talk about types of nephrons. we have two major types. The renal corpus fluid dictates the type of a nephron. When it is in the cortex, we call the whole nephron cortical nephron. When it is near the medulla, we call the nephron juxtamedullary nephron. Juxta means near. Okay, so juxtamedullary nephron means near the medulla. All right. So the later, the juxtaglomerular nephrons, as they have some peculiarities, some peculiar features that make them to engage in countercurrent mechanism. Okay, part of those features are the long blood vessels, that's the vasa recta, the slow blood flow, okay, in the vasa recta, the long loop of Henle, which is deep down into the medullary interstitium, all right, and so on and so forth. Okay, so now we go to the next section, which is the urine concept. So we start with urine formation. Now, urine formation involves three major processes. We have the glomerular filtration, we have the tubular secretion and tubular reabsorption. So we start with the glomerular filtration. Glomerular filtration is a process by which the blood that passes through the glomerular capillaries is filtered into the Bowman space through the filtration membrane. Okay, so it is the first process of urine formation. All right, the filtration membrane consists of, number one, the glomerular capillary membrane, number two, the basement membrane of the glomerular capillary, the visceral layer of the Bowman's capsule. That's the layer of podocytes. The podocytes, they form the visceral layer of the Bowman's capsule. Right? Now, the GFR, that's the glomerular filtration rate, is the total amount or volume of filtrates produced in all nephrons of both kidneys in a given unit of time. Okay, so the normal GFR is 125 mils per minute, or 7.5 liters per hour, or 180 liters per day. Okay, the filtration fraction is a portion of the renal plasma that is filtered into the renal tubule. It is actually 20% of renal plasma flow that becomes the filtrate. So filtration fraction, if you can form that mathematically, is the GFR over renal plasma flow. That's the filtration fraction. Now let's talk about the factors affecting GFR and factors controlling GFR. The factors affecting GFR and factors controlling GFR. The factors controlling GFR will always increase GFR, okay? But the factors affecting can increase or decrease, all right? The factors controlling are the net filtration pressure and the filtration coefficient, okay? Net filtration pressure, that is the summation of the Stirling forces, okay, that act at the level of the filtration membrane, okay? The filtration coefficient is a measure of the permeability and the size of the membrane. Okay, so let's talk about the factors affecting GFR now. We start with factors that increase before we go to factors that decrease. Factors that increase are the renal blood flow. Increase renal blood flow, increase GFR. The tubulo-glomerular feedback mechanism, the glomerular capillary hydrostatic pressure, which increases GFR. Moderate efferent arteriolar constriction increases GFR. Moderate efferent arteriolar constriction increases GFR. Renal arterial blood pressure, increase in it, increase GFR. Surface area of capillary membrane, increase GFR, increase GFR. AMP, that is atrial natriuretic peptide, brain natriuretic peptide, prostaglandin E2, endothelial derived nitric oxide, that is NO, and dopamine. All these chemical substances or hormones increases GFR. Now let's talk about factors that decrease GFR. Factors that decrease GFR are the glomerular colloid osmotic pressure, the Bowman's capsule hydrostatic pressure, the afferent arteriolar constriction, and sympathetic stimulation. Please note that it's only sympathetic nerve fiber that supply the kidneys. There is no parasympathetic innervation of the kidney. All right, then the chemical substance are the endothelins and noradrenaline. Endothelins and noradrenaline, they decrease GFR. Angiotensin prevents decrease in GFR, so note that. Now, so that's actually the section on the glomerular filtration. Now let's talk about the tubular secretion. Tubular secretion is a process by which substances are either passively or actively transported from the blood into the renal tubules for excretion. That's what tubular secretion is all about. And we have some substances that are secreted. We have potassium by sodium potassium pump. That is the use of aldosterone. That's how aldosterone acts, at the basolateral membrane. Okay, we have ammonia, we have hydrogen ions, we have organic acids and bases, we have creatinine, we have urea, etc. Then let's talk about the tubular reabsorption. Tubular reabsorption involves a substance are actively or passively reabsorbed from the renal tubules back into the blood. Okay, the substance reabsorbed actively are sodium ions, potassium ions, calcium ions, phosphate, bicarbonate, most of the electrolytes actually, and the glucose and amino acids are also actively reabsorbed. That is via secondary active transport. Okay, please note that there is no lipid substance that is present, because most of these lipid substances have actually bound with plasma proteins, which are not filtered under normal condition. Okay, so that's why you can't find fatty acids, in the renal tubule, because they usually, bound stay with the plasma proteins. Okay, now most of these substances that are actively reabsorbed pass through the transcellular route. Okay, that is across the membrane. Substances that are reabsorbed passively are water, the urea, and chloride ions. Okay, they can pass through the transcellular or paracellular route. Paracellular is between the cells, between the tubular cells. Okay, the regulation of tubular reabsorption. We have some factors that regulates the tubular reabsorption. Okay, we have a number of them. We have the glomerulotubular balance. Okay, the glomerulotubular balance, which that is increase in filtration respectively cause increase in reabsorption. So as you increase the tubular load, there's no increase in reabsorption of those substances. That is glomerulotubular balance. So it's trying to balance it up so that there is no excess fluid in the tubules. There's no excessive tubular load. Okay, that is number one factor, glomerulotubular balance. Then second factor is hormonal factors, and the third factor is nervous factor. The hormonal factors, we have some hormones increase reabsorption of some substance, while some decrease their reabsorption. For instance, aldosterone increase sodium reabsorption and decrease potassium reabsorption. Atrial natriuretic factor decreases sodium reabsorption. Likewise, brain natriuretic factor and C-type natriuretic factor. So you have ABC natriuretic factors. Okay, parathyroid hormones increase calcium ion reabsorption and phosphates excretion. Calcitonin decrease calcium ion reabsorption. Alright, angiotensin increases sodium reabsorption by causing the release of aldosterone. So now let's continue on the fifth part of the presentation, that is talking about micturition and micturition reflex. Micturition or urination is a process of emptying or voiding the urinary bladder. Okay, a reflex that triggers this process is called micturition reflex. The bladder receives autonomic innervation of both parasympathetic and sympathetic nerve fibers. Okay, so as the urine accumulates inside the bladder, droplets enter into the neck of bladder, which stimulate the stretch receptors. Okay, sending impulse to the sacral segments, that is S2 to S4, of the spinal cord via the pelvic nerves. Impulse is sent back from the spinal cord via the parasympathetic nerve fibers to cause the following effects. Number one is the contraction of bladder detrusor muscle. Okay, number two is the relax of the internal urethral sphincter, and number three is the stimulation of some other acts that will induce the feeling to micturate. Okay, so micturition itself is voluntary at early stages of micturition reflex before it later becomes involuntary, that you have to be forced to micturate when you are being pressed. Okay, so that is micturition and micturition reflex. Now let's talk about renal pathophysiology. The renal pathophysiology some of those conditions that cause abnormalities of the kidney and the renal system. Okay, we have renal failure. That is the inability of the kidney to perform its excretory function. Okay, we have two major types. We have the acute and chronic. The cardinal sign of renal failure is actually decrease in GFR. When the GFR decreases, then you sense there is renal failure. Okay, so acute and chronic, that's to do with the time, the duration. Acute as when you have some cause that just cause sudden inability of the kidney to perform its normal function. And chronic is prolonged. Okay, other pathophysiological conditions are like anuria, that is total absence of urine, that is there's no urine. Oliguria is few urine output. Hematuria is the blood in the urine. Proteinuria is protein in the urine. We also have nephritis. Nephritis can be acute or chronic too. That is the inflammation of the kidney. Okay, so all these pathophysiological conditions that can cause impairment in the function of the kidney. So that's actually round off the whole section. I wish you all the best. You will succeed. God bless you.